All right, so here are my notes for simplifying polynomials. My goal for today, or after you leave, or after you're done watching this, you should be able to simplify polynomials by combining like terms. Now, the most important definition of this whole entire year has been like terms. And like terms are two monomials that have the same exact variable. We've been talking about this really all year, but we're going to make it a little bit different today because we're dealing with polynomials. Why this is so hard. Most students see x to the third and they say that the variable is just x. For today's lesson, we're going to say that the variable is really x to the third. So in order to be like terms, they both need to have x to the third. So if I want to talk about examples of like terms and non-like terms, one of the biggest things that people mess up are things like x and x to the third. Those are not like terms. Even though they have the same letter, they don't have the same exact variable. We want x and x, or x to the third and x to the third. So an example of like terms would be x to the third and x to the third. Okay? Another example of unlike terms, obviously, are things like x squared and y squared. They need to be the same letter as well. And some examples of like terms, again, you could just do like 2 and 5. Those are like terms. You can always combine those. All right, so next thing, can you tell me why x plus x squared is equal to x to the third is wrong? So think about it for a second, and let's see if we can come up with something. All right, so the biggest thing that I see that's wrong with this is you cannot add these two. They're not like terms, first off. And second off, if you really wanted to make it x to the third, it should be multiplying. Should be multiplying. And we will multiply later on in this chapter, but we're going to start off just by adding. So we're going to start off by putting things that are like together. Now, one big tip that I'm going to give you guys when you do these, and I talked about this yesterday too, is when you see a big old polynomial like this, split it up. Draw lines down before the signs. Everyone see how I drew them down before the signs? So now I see that I have 4 different terms. Are there any of them that have the same exact variable? 3x to the third and 7x to the third. They have that same variable, x to the third. So now I can combine these. 3x to the third and 7x to the third is 10x to the third. And I like to scribble them out when I'm done with them, just so I know that I've handled that. Now, are there any other like terms up there? I have just a straight up x and an x squared. Are those like terms? No, they're not, because they don't have the same exact variable. So I'm just going to write down everything that's left. Plus 4x plus 2x squared. And that's it. That's as much as I can do. Just like in the beginning of the year when I would give you guys stuff like I'd say simplify that, and it would turn into 10x plus 5, and that's it. And you'd leave it just like that. It's exactly what we're doing today. We're just going to step up the difficulty a little bit. All right, so on the next page, I have us doing example 2. We've already done this. This is the last example. Example 2, though, says simplify the following. Now, a lot of people, when I say draw those lines down, do it right away. You need to do something first. When we solved equations and inequalities, we always distributed first. So let's do that, and then it's going to turn into what we just did. So now when I distribute, I end up getting 21j's minus 3j squareds plus 2j's plus 10. And now that I don't have any parentheses, now I can draw those lines down and combine like terms. So let's draw those lines down. And how many j's do I have? I have 23 j's. I have that negative 3j squared that I can't combine with anything else, and plus 10. So the simplified version of that is this down there. Should be pretty easy for us today. The only thing is we're not completely done. There's honestly something more that I can do to this answer to make it a little bit more, I guess, math good for math, and that's putting it in standard form. A polynomial is fully simplified when all like terms have been combined, so that's what we've done, and it is in standard form. Now, you don't know what that is yet. So the definition of standard form. The terms are arranged so the degree, that's what we talked about yesterday, how many variables are in each term, of each term decreases or stays the same from left to right. Does anyone remember how to find the degree of a term? I basically just said it a couple seconds ago. It's how many variables that term has. Term has. All right, so let's do a couple examples like that on the next page. I like to do this all in one step. Sometimes when I look at books and they have us doing this, they do what I did, and then afterwards they have us putting it in order. I like to just put it in order and combine things right away. What I do is I separate all my terms. So let's draw these lines down like I've been doing the whole time. Then find the term with the biggest degree. So this is me doing it all in one step. So what's the term with the biggest degree? Instead of asking, is there anything here that I can combine? Let's say, what's the biggest one? And my biggest one is y to the fourth. Is there anything that I can combine y to the fourth with? If not, just write it. Okay? And see if there's anything to combine it with. And there wasn't. If there's not, write it down and then move on to the next biggest degree. So my next biggest degree after 4 is typically 3, but there are no 3's on here. Then it's 2. So if I have 7y squareds minus 5y squareds, would have more of positives or negatives? Obviously positives. So 2y squared. And then last but not least, 3y. So plus 3y. Again, I cannot combine this one and this one because this one has a 2 and this one has just 1y. And I'm done. And if I want to check for degree, I could draw my lines down to separate. That one has a degree of 4, that one has 2, and that one has 1. Is it really decreasing from left to right? Obviously it is. All right, so let's do one more example. I'll have you guys do a couple on your own here. So put the polynomial in standard form. I'm going to draw my lines down to separate. And I'm going to say, what's the biggest degree that you guys see? Obviously it's 8. So how many x to the 8th do I have? If I combine them, how many do I have? I end up having 4x to the 8th. So now that I have that, let's combine some other stuff. I see that I have a bunch of x squareds. So I'm going to go minus 8x squareds because these two can be combined. And then last but not least is that 2x. Is it positive or negative? There's no sign in front of it. It is positive. Okay, again, if you wanted to check, you could. Is this really decreasing in degree? 8, 2, 1. Yeah, it's definitely decreasing in degree from left to right. Okay? All right, so would you guys please pause the video, try these two on your own, and then unpause it when you're done to see if you got it right. All right, hopefully that was enough time for you guys to pause it and unpause it. So for number 7, are there any like terms there? I don't see any, so all we need to do is rewrite it so it's in standard form. My biggest one is this x to the 3rd, so I'm going to write that one first. Then the next one is positive 5x squared, and last, minus 11. And that's it. That's really all we're doing today. Number 8, are there any that I can combine? There are, but is the biggest one? No, so I'm going to put this one first, 4d to the 4th, because that's my biggest degree. And then if I have negative 1 and positive 4, I have positive 3d squareds. And that's it. Some final thoughts for today. Like terms have to have the same exact variable, just not the same letter. 3x squared and 4x are not like terms. For a polynomial to be fully simplified, it must have no like terms, and it must be in standard form. And remember what standard form is. the terms have to decrease in degree from left to right. And that's it, guys. Thank you for watching.